the screen. So my screen is visible here. And I am audible too. Just I am audible, yeah, and visible also. The screen is visible, yeah. Okay, I'll assume so. Welcome all to the week 8 discussion of research methodology in natural sciences. I am Udiptya from IIT Madras, and so before going to that one, the today's questions maybe today's topic essentially. One of you had asked about this question, so I thought today we will first solve this one and then we will go to the rest ones. So this is a question from the error propagation, yeah. So a question from the book. So if you have the book, it's from the exercise. It's exercise question number 10 from chapter 6. So yeah, you all can try and then we will try to solve it. So this is a question from, I think, so this week 7, yeah, error propagation. So the question is understandable, or should we break it down? So who had asked this question? Is he or she here in the meeting? Who asked that question? I also saw that they have issued the solutions for the past questions. I think now it is addressed, I suppose. Yeah, you all had some issue with one question maybe. They have revised the answers, I think. So you all are doing it now, the question, or should I solve it? So for the new joinees, this was asked as a doubt in the last class. So I took it up in the first. So basically, before starting our this week's topic, I thought we will solve this and then we will proceed to today's topics. So this is a question from chapter 6 of the book Research Methodology Natural Sciences. Question number 10 from that, if you have the book. So I think people are trying it, so we'll wait some time. If you want that we solve it, you all can write that and then we can start solving it. So if the terms like T, L and G looks alien to you, so the uh, T is the time period. L is length and G is acceleration due to gravity. Okay, so yeah, those who has done physics will know this one, this formula. So yeah, these all are given. So to calculate, so this formula is given, so we'll bring this here, t equal to 2 pi root L by G. Okay, or but we can write this. We can also bring the 2 pi here and also write it as root L by G. Yeah, I don't know, am I audible or not, or today all are being very silent.
Your audible, sir.
Okay, yeah. So yeah, so basically we are solving that question, the doubt question. So yeah, um, so yeah, where was I? So yeah, so then we can remove this root by squaring both sides. Okay. What it comes as G equal to 4 4 pi square by L by T square. Okay, so then we can put the value of L. L is given as 0.381 meter. And T is given as 1.24 second. So yeah, calculate it. some time. I'll calculate it. Till now, if anyone has doubts, they can ask. So it is coming as 9.78. So what will be the unit? What is the unit of acceleration due to gravity? Nobody?
Meters per second square.
Yeah. So meter per second square. This is the unit of. Otherwise, you can also derive from, like, take out from the formula. But yeah. Then now this is the absolute value. Okay. Now we have to calculate the error. So this till this it was kind of a easy task. But then you need after this you need a small amount of differentiation that I told. So you have g equal to 4 pi square L by t square. Okay. So you will now have to find dg by dt. Okay. So what will be this? Differentiate it. So in differentiation, the constants won't be affected, only the term that is so this the term of t square, this will be affected only. Anybody differentiated?
Minus 8 pi square L upon T, I think.
Minus 8 pi square L
Divided by T.
t.
Uh,
Or is it will be t cube?
okay, sorry.
Yeah. So this will be the differentiate different after differentiation you will get this. So I'm not going into the basics how to do it essentially because it's not in the part, but uh, these are the basic rules actually. So yeah. So dg will be 8 pi square L by t cube into dt. So now you can input the value here of all the terms. We have L, that is 0.381, T as 1.24, dt as this one. Yeah, so can we calculate this?
Excuse me.
Huh?
Is it like 18 pi square by t cube?
Not getting it. Why? What?
Derivative.
Huh?
Is it not 18 pi square L by t cube?
Voice is breaking. Can you write?
Am I audible?
Can you write on the chat?
18.
18.
That number is 4. It is not 9. That is why it is.
I'm not getting it. Which one?
I think what she is trying to say is if we see the first numerator, 4, it is 4 pi square, not 9 pi square.
Oh,
So
okay. Yeah, it's 4,
maybe
4. Yeah, from this one. Yeah. So, how much it is coming? This is 4, okay? Yeah, as I told, this 4. I have written like kind of confusing. Minus 1.577. Others are also getting same. Minus 2.4279. Okay, then I have to calculate it. Minus getting this. Minus 8 pi square. For me it is coming 0.007. Okay, anyway, yeah, that's the error in terms of t, yeah, that we can calculate, no issue. uh, so the thing is, now we have the error due to term of t, and so another term was the least count of the scale, so that will also have impact on the uh, impact on the basically on the measurement. So now we have seen the propagation of error, yeah, how it is when we have error given in terms of uh, in terms of okay, 0.1 second, and yeah, then one thing is there, this dt essentially will not be 0.1, because this we saw, yeah, this is the standard deviation. We have to take the standard error here, so we have to essentially, for standard error, we have to divide the standard deviation by the number of iterations, the number of terms, then we have to put it here, yeah. So the length also has a error of 0.381 plus minus 0.02 or 0.02, yeah, meter. Okay, so these two errors you have to incorporate in that using the division rule that we told. Okay, so the next one, some of you have solved this one, yeah, the last question that I told in the during the last discussion. How many of you have solved this? Has anybody solved this? So what will be the first step here? Can anybody tell what will be the
Rearranging
first
in
step?
ascending order, I
Yeah,
think.
yeah. So can anybody tell what it will be that? Okay, if you want to try now, you can try now, then we can solve it. I suppose people have not done it yet. And then after ascending, tell the Q1, Q2, and Q3. And also the interquartile range.
Sir, here one value is repeated 4.9 twice.
Hmm? Okay, yeah, that's not an
4.9
issue.
will write it twice.
Yeah,
Okay.
anybody got? Q2 4.15. How you got Q1? Acha, first tell Q2. What is it? Q2, how you got?
There are 25 data points.
Okay.
So middle term will be 13, 25. Middle term will be 13th term.
Okay. 13th term is?
Is 4.9.
Okay. So Q2 is 4.9. And Q1?
Q1 is 4.1 plus
How
4.2 divided by 2.
how you got?
Uh,
So we have how many terms?
Before 4.9 there is 13. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 terms. Before 4.9 there are 12 terms.
Okay.
So we take 1, 2, 3, 4, 5, 6 and 7 data point and divide by 2.
So you get 4.1.
4.15.
Okay.
Yes.
Okay, we will take yeah 4.15. Okay. Then Q3?
Q3 7.
7.
Q3 is 7. Yes.
How you got?
6.9 plus
Average
7
of
points
Okay.
divided by 2.
The IQR?
7 minus 4.15, 2.85.
Okay. So is there any outlier? How to find outlier?
4.15 minus 2.85 into 1.5.
Okay.
Over.
Q1 minus 1.5 IQR. So is there any? How much this value is coming?
Minus 0.215.
What? Okay. So is there any
One outlier 11.3.
11.3? Okay. 11.3 is the outlier. Any other? So this one? if you have a report measured value in a scientific journal, how do you represent it?
Yes, sir. What is the answer of this? How to report this?
Yeah. So what are the statistics we have to report?
All these things will define there.
Yeah. And additionally, mean, median, median you have given. Sorry. Standard deviation. So you have to find the mean and the standard deviation. So you have calculated the mean and the standard error.
Mean is 5.433
Five. So it's including the outlier or without it?
without outlier.
Okay. What it is coming?
5.433.
5.433. Others are also getting that? Mean, everyone is getting this one?
standard deviation will be 1.473, 1.7437.
Uh, I don't know actually. I have to also calculate. I have not. How much you are getting? Standard deviation?
Standard deviation 1.7437
37. Okay.
and standard error is 1.7437 divided by 20, root over 24. It is coming 0.356.
It's coming?
0.356.
Okay. Others? This is coming? So how to proceed ahead? With what level of confidence can you state that the actual value must be below 7.5? So how to do it?
Sir, one question, sir.
Yeah, tell please.
Sir, during calculation of HD, will you consider the outlier?
Uh, you should not actually. So when you find the outlier, so after that it's you will not consider it for the other
Will
like
reject it, no?
reject it.
Sum the all the difference.
Yeah, yeah.
Where-
Then for mean and everything, for the next thing, you have to reject it, to
Okay.
ignore it, avoid it.
Okay.
So how to go about the next thing? So anybody has any ideas how to go about it?
I think it would be z is equals to 7.5 minus mean by standard deviation.
Yeah, then because it has 24, uh, then we can yeah, we have to go for we can go for t-test actually because it has 24 terms. T-test would be a good thing. Plus we have the degree of freedom as 23. So yeah, we can calculate it accordingly. So what will be the term here? Next test.
Equal to x bar minus mu by sigma.
Yeah, divided by the standard error. So this will be 7.5. minus the mean divided by the standard error. So I am assuming you have calculated it correct. The degree of freedom is 23. So how to calculate it? It is n minus 1. Okay. So the rest of this, like, then rest you have to just check the value whether it is how much it lies on the t table, and so what significance it lies, and then you can tell that what confidence you can state that it will be below 77.5 ohm. Or you can also consider it and compare it with the 95% value, and then you can say it's with what level of confidence you can say it can be more than 95% confidence that you can say.
It's 5.806.
Which one? This one?
The T one.
5.06.
806.
Okay. So then you can calculate. Then you can check it from the T table. Okay.
At
So
what confidence level we check?
you can check at 95 or so, then it's not an issue. Just you can tell, okay, 95%
If the
is a good.
confidence level is not given, we should consider by default 95% confidence.
You can take it as default, or otherwise here you have to tell that with, like, if the value at table is smaller than this, then you can tell it is more than 95%, like with more than 95% confidence you can tell that this value
Because
would be.
sometimes in the question also it is given like 95%, but here it is not given. Which
Here
level
it
of
is not,
confidence can
yeah,
you state that actual value must be below
below.
7.5
Yeah.
milliohms?
So 95%, yeah, you can take it as a kind of a standard also. But you can't tell
Okay.
it like that, but yeah, but if it's like that, yeah. People, but you can't tell it as standard, yeah, because you can have some questions may have like 99% or so. You only will see two numbers, either it will be 95 or it will be 90, 90 what 97 99, yeah. So yeah.
Yeah, excuse me, sir.
Significance of 0.05, right?
Yeah, 0.05.
So it comes around 35.172.
37.
35.172 at 23. Degree of freedom is 23, no? Because 24 was the
Yeah.
n minus 1, 23. So 23 versus 0.05% significance. It is 33.924.
33.33, like
Just a minute. 35.172.
you are telling me the t value, yeah?
Wait, I'll just check whether I'm appearing the right table. You have it? Can you feature it on the screen? Because I have one wherein degree of, but whether it is for the t value, I'm not getting. Because I've just taken the screenshot when we are doing last time.
No. That will be like t value. T will be like here we will have DOF, and then you have here significance level. Significance level. Here will be 1, 2, 3, and to go to
Yeah,
20.
like that only it is.
Okay,
Area
sir.
under.
Sir, for degree of freedom 23,
Uh,
5.806 is not there, means it will be very much less. Even in
5.806 will not be there, but it will be in some other value.
It,
So is it less than that, or what value is it?
actually in point one that is 3.767.
3 point
See 767.
3.7.
can you, sir, can you please put that t table over there?
Yeah, I can. Have to
Sir,
search.
for 23.
So t value table. Here we have. Okay.
Hmm.
So the 23, it's 1.71. Yeah, this is the table I was referring to. I was telling
Yeah,
you.
yeah, yeah. I was referring a wrong table.
Yeah, so if it's greater than that, then you can confidently say, okay, it will
So
be.
yeah, at the significance of algebra. So it is greater than 1.7,
Yeah,
1.738.
1. Yeah, this one.
Yeah, 1.17, 13872.
Yeah.
So T is greater than that, so that means the out of the range.
No, out of the range, nothing is out of the range
Out of
actually.
means greater
It's
than the.
Yeah, it's the kind of a base level. Yeah, if you cross that, so you are statistically on that range. It's not like out of range. There's no range actually, just one value. If you are
So now
not
the last statement with the with what level of confidence can you state
uh,
that the actual value must be below 7.5
yeah.
milliohms?
Hmm.
So how do we conclude this? Like,
You can tell it's like with 95%, or you can say actually from 99 also, that it's because it is greater than that also. So you can state so whatever will be the close, 99 will be the best answer actually, because 23 at 23, 99% is 2.807. So yeah, you can tell 99% confidence that it will be below 7.50. That will be the answer here. Essentially, because these questions are these questions mostly are like subjective. Like I have given subjective, but yeah, if you have objective kind of questions, then you have to see. If you have nine options as 95 and then 99, then you have to select the one that is 99.
mm,
That will be the better answer here.
yeah,
But
if the confidence level
yeah,
is given, then we don't have a
yeah,
choice. We have to
yeah,
select that only and write the answer,
true.
whatever it
Because
is,
these are only
right?
single values, so you can't.
Mm.
Yeah, so you can't, because then 95%, 95 is also correct actually, but the most correct is 99.
99.
Yeah.
Okay.
That's
So it is lesser than 7.5 milliohms. So
yeah, it will be like 99%. We can tell that 99% confidence.
okay, thank you.
Yeah. So okay, then after 1 hour we will start the today's one. So yeah, Swapnil has yeah, please.
Yeah, sir, sorry to interrupt.
No issue.
I have a difficulty in week number 9 assignment. Is it possible to address in this session?
Actually no, because yeah, kind of
Okay.
because it's
Because
ongoing
the
thing.
due date was around
Yeah, I
29th
know.
of March, so that's why I asked.
Yeah, we are in a difficult and like difficult position that we are
Oh,
not allowed kind of
okay. No problem. Thank you very
yeah
much.
with the assignment ones, but yeah, conceptually maybe we can discuss on that.
Um, Sir, do this book of the reference book of this natural sciences by
Mm-hmm.
Sir Dr.
So Mitra, yeah.
Banerjee. So basically, I wanted the book of that, but I am not getting. So anybody has the PDF of it by any chance?
If anybody has, just yeah, just ping her, like write in the chat maybe, yeah.
Yeah.
Yeah,
Do
you
anyone
are.
has that?
Then you
So
can
can share with me, please.
yeah. Okay. If anybody has, they will tell me.
Yeah, I think they don't.
Yeah. So
Any you have
I have the
sir,
physical book, so
you have to visit. I'm not getting that book from long time actually from Amazon also, so that's why.
okay. So this week's topic is on hypothesis testing. So we just it is a kind of a repetitive PPT or slide. That hypothesis is an assumption, an idea that is proposed or for the sake of argument, so that it can be tested to see if it might be true. And it is usually tentative. It's an assumption or suggestion made strictly for the objective of being tested. So examples of if then, like some research hypothesis, yeah, some hypothesis that if a person sleeps at least 6 hours, the person will be active than if the person sleeps less than 6 hours. This is just a hypothesis. Another one is if a ball is dropped, it will fall towards the ground. Similarly, if coffee is taken before going to bed, then it will take longer to fall asleep. Then we have different types of research hypothesis. Research hypothesis is a statement of expectation or prediction that it will be tested by research. In hypothesis, the relationship between variables is predicted. So we have seen this kind of from 2 weeks of our course. Then we have another called as null hypothesis. So it is which is denoted by this H naught. The null hypothesis states that there is no relationship between the two variables being studied. Example: rigorous exercise has no effect on the heart rate. So there's kind of a no relationship. And in alternative hypothesis, the alternate hypothesis states that there is a relationship between the two variables being studied. One variable has an effect on the other. So example is doing rigorous exercise increases the heart rate. Okay. So the alternative hypothesis is usually denoted by HA or H1. So it will be using less than, greater than, and not equal symbols. And if null hypothesis is rejected, then it is assumed that there is enough evidence to support the alternative hypothesis. Okay. So we can't tell. We have to tell that there is enough evidence to support the alternative hypothesis. We can't tell that the claim is proven to be true or false. So a Z-test is a statistical test to determine whether two population means are different when the variances are known and the sample size is large, that we have seen. So it can be used to test hypothesis in which a z-test follows a normal distribution. This also we have seen. So and then we have two types of terms here, z-test and t-test. So z-test is used when sample size is large or the population variance is known. So for now, this is, we are considering 25, yeah. Then 25. T-test is used when sample size is small and the population variance is unknown. So the scientific hypothesis must be testable. A scientific hypothesis must be falsifiable. So these terms are we have already discussed in our previous classes. Just some brief. So some basic hypothesis testings to make your life easier. I thought to just make it in a step. So the first step will be specify the null hypothesis, then go for the alternative hypothesis, set the significance levels. Mostly it will be in the either in the question or you have to set it on your own depending on the conditions. Then you have to calculate the test statistic. So here it will be either z-test or either t-test mostly, and the corresponding p-value, and then drawing a conclusion. So this will be the last step. So this is a step I usually follow, or kind of a standard test. So just giving it the brief. So this is the z-test, yeah, that we have seen that z-test is used for large samples. The population is assumed to be normal distributed. The sampling distribution of the mean is normal distributed, and the value of z is sample mean versus population mean, standard error of the mean. So this is something we have already seen. So acceptance or rejection of null hypothesis. So if the area under the normal curve corresponds to the value of z is less than the stipulated confidence level, then the null hypothesis is not rejected. Okay, so for null hypothesis to be rejected, the z value should be less than the stipulated confidence value. So then the null hypothesis is not rejected. And if the area under the normal curve corresponding to the value of z is greater than the stipulated confidence value, then the null hypothesis is rejected. Okay, this is the two conditions. If the calculated z is less than the table value at a given level of confidence, the null hypothesis is not rejected, and just a repetition here. Okay. Then we have similarly a t-test. So in t-test, a statistical test used to compare the means of two graphs, and it is also a bell curve. Okay, and so here you can see the difference between the z and the t. Okay, so a t distribution is a type of normal distribution used for smaller sample sizes, and in a t distribution, the estimated based on the degree of freedom of the data set. Total number of observations minus 1. The t distribution gives a lower probability to the center, and these all are on the distribution, and the higher probability on the tails. So you can see the difference here. On the center it is less, and on the tail it is more. So that's what it is telling. The t distribution is most often used to find the p-value or the confidence interval of a statistical test on a given data. Okay, these are the two tests we will be using. And then there is something called as a chi-square test. So it is also told as independence of attributes or goodness of fit test. So goodness of, some people also tell in some books it will be like goodness of fit test. So those who are from biotech might have, or those who have done genetics will be aware of this method. So yeah, so this was given by Carl Person in 1990. And it is related to the standard distribution. If a random if a random variable x has a standard normal distribution, then the chi-square has a chi-square distribution with 1 degree of freedom. So degree of freedom also plays a role like t-test here. So then these are the independent standard normal variables. Then the chi-square x square with k degrees of freedom. So degrees of freedom is also there, that how much independent variables are there. Okay, so it tells us what is the goodness of it, like comparing with the expected and the observed values. So whether the observed data comes from the given theoretical distribution, whether attributes in a given contingency table are independent, goodness of it. So this is the formula, yeah, for hypothesis testing, that chi-square. So it's also the same, that if the chi-square value is more than the test value, like the calculated value is more than the table value, the null hypothesis is rejected, and if it is not, then the null hypothesis is not rejected. So I just breezed through it because of the time.
Please show that previous slide just for a second. Okay.
Okay. So some problems. Okay. So this I have written as V and W, and yeah. So the other VW, VL, VW will be this very low weight babies. So what test we are using here?
So J test.
Okay.
Yeah, the sample size is bigger here.
Yeah, so how you are doing it?
So z equal to xc bar minus xc bar by ec, no? By that formula.
Yeah. Then what will be the standard error? What it will be divided by? So you have to use this formula. Basically, this is the same one. Just z equal to x1 x2 standard error. So when we have two populations and two errors, we saw that error of propagation. Yeah. So what will be the answer?
Sir, is it 3.5?
Yeah, I think so. This will be root 15.1. So what will be the conclusion? What will be the conclusion? Can you compare it with the Z table?
Okay, okay. So conclusion will be there is enough evidence.
Yeah,
More than 99%.
yeah, correct. So others have got. So this value can be plus minus 3.5. Yeah, everyone gets it. Yeah, that doesn't matter actually. The z can is a symmetric curve, so it can have both positive as well as negative. So as is told, 3.5 I have taken. That's why in most conditions you will have this as plus minus z or something kind of like this. Okay, should I move ahead?
So this value of minus like 3.5
Uh,
on the Z table,
uh,
how do you read? Just a minute.
sure.
Again, here we will be seeing 95%, is it?
Yeah, you can see, but yeah, it will be I think more than that also. I think. I don't know. I haven't seen, but yeah, like if it tells that is there good evidence that mean IQ is lower, you can tell yeah, 95% or so.
So 0.502 at 95% confidence.
95% is I think 1.96. Yeah.
Uh, I'm just seeing the standard normal table Z. That is the only one, no?
Yeah.
Okay. Here the values are till 3.4 only. So what did you say? Sorry, I missed it.
What?
You said
You
something.
everyone can consider z value at 95 as 1.96. So now you have to compare whether this 3.5, if it's less than 1.96, okay, like, yeah, you
3.5.
can't. So whatever the answer will come, the Z test, okay, if it will be less than Z95, then the null hypothesis is accepted. Okay, and if it is more than that, then this is rejected. Okay, now the value z test is 3.5. Okay, so is it less than or more than the table value 1.96? So we know that it is more than 1.96. Yeah, that's why we are rejecting the null hypothesis.
Yes, yes.
That's the thing. Yeah. Okay. So a similar kind of question. So So you have one, this is the kind of a control, and this is a disease, neonatal asphyxia. I suppose it is with the asphyxia usually deals with, I think, the respiratory, like the amount of oxygen or so. I think so. Yeah. So like if the kid is like neonatal, means the newborns, yeah, are they deprived of oxygen or not? So that's the neonatal asphyxia.
Sir, is here 14 is in control group.
14 is
In control group.
what group?
Control.
No, this is the control, yeah. Normal.
NC 54. Or total is the experiment. Is it right?
I'm not getting it.
If NC 54, then what is NE?
Uh, so this is the normal one, the kid with normal oxygen, and this is the kid with neonatal asphyxia, and this is his systolic pressure, the blood pressure. You can take it. So, yeah. So normal is the control one. You can take normal as control also. And this you are supposing to be taken experimentally, yeah? A similar kind of question. So you have to tell the relation between.
Three point eight people.
I don't have the answer. Sorry. Plus, I don't have a scientific calculator also.
Divided by under root of 36 by 52 plus 25 by 40.
Yeah, actually, I don't have.
Okay.
So I'm unable to solve.
No problem.
think so. This comes, yeah.
Sir, how is it 21, sir?
75 minus 69. Okay, sorry. How much it comes?
The 6.
Okay.
6 divided by 25 is under the
Sir, Z is 3.84.
Okay.
I got 3.833.
Yeah. It's, yeah.
So that is,
So we can say that null
it
hypothesis
is
can.
greater than 1.96.
Yeah. Then we can reject the null hypothesis.
Reject the null hypothesis.
So it's kind of similar. Yeah. So this is a question from the book actually. So I've just taken the snap and provided it. So we have to check the goodness of it, yeah.
How to attempt this?
So this is chi-square. This question is
Right
from
side.
yeah.
Okay.
So usually when you have when they tell like they have expected and observed and they compare the two values,
Hmm.
most probably it will be a chi-square test. Can anybody tell what is the degree of freedom? So here degree of freedom comes simply.
I think 9, sir.
Anybody?
9, I think.
So a degree of freedom usually means the number of independent parameters here. The thing is, so when you have a so here all the terms are independent of each other. So the number of independent terms here it is 10 only. So like if you have so suppose uh, in some conditions you will have the total as fixed, yeah, total as fixed. Then what you have is that last term, like you the total should be 10, then you have 5 in the A category, B and C, 5, and then it is without telling C, we know that it will be 0. So that in that conditions, the degree of freedom will be n minus 1. But here,
Yeah.
as all the wavelengths are kind of independent, we will consider the degree of freedom as 10.
So, you want to say here, if at all, I didn't get you why the degree of freedom will not be
So the
because we
degree
have
of
number of samples as 10. That is the reason.
no no no
So it is
so
more
no
than
no
10. No, I didn't get.
degree of freedom means degree of freedom means that how much is your sample set. Independent samples are how many independent samples you have. So if there is a boundage on, so if there the total is bounded, like the total should be like I you can collect think you can collect 20 items, okay, in a set. So what you will do is, in one bag you have three bags. How will you collect? Maybe first you collect 15 in bag 1, 3 in bag 2. So C, without giving the C, as the total is fixed, you know that C, the number of items will be 2. So this C is not a dependent variable. This C is a dependent variable, not an independent variable. In such conditions, you have to take what the number of independent that I told in the PPT. Yeah? The number of independent random variables should is the degree of freedom. So I have to just check the table. So for d equal to 10, the degree of significance 0.05. The table value is 18.307.
अविरल नहीं है ना कमल.
So how are you calculating chi-square? long calculation, yeah.
Sir, is this square in denominator also?
Huh?
Is there square in denominator also in square space?
Yeah.
1.21 square.
Calculated? So 14.177. So what can we conclude from this? Yeah, so it is below the critical value. The critical value for to be like to be considered with the theorem. So the critical value was 18.307. So it is smaller than that. So we can't reject the null hypothesis. Yeah. Should we go ahead?
Sir, 1.21 square or 1.21 only?
1.21 square. So you might be you are, I think, confused with the so there are so chi-square mostly in two conditions, like when you have the um, you have different categories and you have to compare them. So there is one so chi-square is like observed minus uh, observed
Expected, yeah.
expected, and then the whole square divided by the
Yeah, why expected only?
yeah. Another one, when you have this expected and observed means, we usually have the standard error also, yeah. Then we put as O minus E, and then the delta O ka whole square.
Okay, thank you, sir.
Yeah. Should we move ahead?
Yeah, I didn't get this what you said. We usually observe minus expected divided by
Okay, so this, when you have this expected and observed, and you have to compare these two theorems, and you have the standard error. So you have to consider this formula of chi-square. Okay, this is called for comparing measurements with expected values. And another
mhm.
one is like you have two categories, and then you have observed and experimental. This observed and expected, and then you have then you don't have the standard error. Then you have to consider this formula.
Then in that case, we should use the second formula which you have
Yeah.
put it.
Sir, sir,
Mm.
am I audible?
Yeah, yeah, please.
Sir, actually, I have a little query on the problem number 6, which were earlier you discussed. Just a little query. So after this problem, you can just focus some light on the area.
Sure,
Actually,
sure, sure.
in that problem. Okay, sir.
How to solve this problem? Because this is again some comparison here, I think.
Yeah.
So this and the level of significance is also given, and different degrees of freedom has been given.
Yeah.
So
So usually the questions will have different degrees of freedom given, just to confuse which one you should use, because they won't give that table. So they will just see, okay, what the student might be confused with the degree of freedom, and then they will give it.
okay.
Yeah. That's
So
that's
we should not look into that. Is it you want to say in the beginning, or
yeah.
after getting the values we can
Yeah, yeah, yeah,
tally?
yeah. So because they won't give only one single value, because yeah, they want to confuse maybe. Yeah.
Okay.
The conclusion, if we null hypothesis, we cannot reject.
Hmm?
Null hypothesis, we cannot reject. No, actually it is 9.95 coming. And degree of freedom is 3 here, no?
4.
4. Sir, here the total number actually 3, we can get the 3, then we can get the fourth one, no?
No, it is not said that the total number is 2000, yeah?
Fourth one is also independent.
Yeah. I just put the I just made the solution because I thought this I can't complete because of the time. Last time it was happening, so I thought let's put the solution. That will be easy.
So can you explain this once?
Yeah. So these are the two hypotheses. The null hypothesis is that the result of the experiment does not fit well with the theory. And there is the reverse, that the result will fit the theory. So total number of beans, we find it out at 2000. And then,
Because the mean is not given here, so we are calculating this.
yeah, we have calculated it. So this is calculated just because we have to find what is the expected number of if we had if you had followed the theory, what would have been the expected number of things in each of the groups, or essentially bags. Okay. So what will be there in each of the bag? So for that we calculated this one. So the observed was so yeah, that's how we did it. Then we find out the expected. So expected. So we have the proportion and we have the total number of one. So
Yeah, 4 is to 3 is sorry, 11
Yeah.
is to 4 is to 3 is to 2.
So then we can find out this one. Then it was same as the chi-square formula that I told. This one.
Yeah, observed value minus
Yeah.
expected value divided by
Yeah.
square root.
Then we have the degree of freedom as 4, and I had given 9.488.
Because we couldn't get the direct values of the observed and the expected, we have calculated these ratios
Yeah.
for the observed and expected, right?
It's like yeah, you can tell it like that, or you can tell it like these are the values that are expected from the theory. So in theory, this is the proportion that we are getting. So yeah.
Yeah, 11 is to 3
So
is
this is
to
through theory and this is through the experiment. So yeah, that's what it is. Okay.
Sir, can you go back in the problem number 6? I had just a little query
Problem
from
number
that.
6. Which
Mr.
one?
Box plot.
Oh,
The first problem.
yeah.
Yeah, sir. Right. Sir, in that problem, actually, I asked in the chat box that time. So, when we calculate the standard deviation, actually, we are testing here the t, no, right, sir? It is yes, sir. So, when we calculate the standard deviation, that time there are two formula for the finding out the standard deviation. I mean, root over of 1 by in the denominator part n minus 1, and another formula is n. So here,
Okay.
which one is accepted?
So here you can take the n. for the t-test.
N, no, sir. But sir, N is for the actually what I studied in the book, that N is used for the population case. I mean, here we are accepting the t-test, so we are using in the below
N.
25, but also accepting the N. So that is why my result was different at that time.
Okay,
So I calculated in the latter
For
one.
t-test and for for t-test you will have to use the n. So yeah, so
We'll
this
accept,
we
denominator
have
for
to do it.
20.
Yeah, for t-test also
Why,
you have to you
why
have to
it is
do.
like that, sir? That for t test we should use n, and for z test n minus 1.
So like it's difficult to explain actually. So there is some correction term they usually tell it as. I forgot that name.
So,
So for
so
the
you want to say कि if the sample size
hmm,
is higher,
hmm.
so when the sample size is higher, they are taking they are removing that error, right? And
Yeah,
if the
so
sample
for
size is
samples
lower,
they will have n minus 1, and for populations you will have n. So yeah,
because it is a size of the data, because of that.
size of the data, yeah.
Yeah,
So
because more the sample, the error will be less. So same
yeah,
logic.
more or less in that this error is mostly in terms of z. When you will have z, you will have this thing, but in t
Yeah, Z.
you will mostly use the n only, because you then have a degree of freedom, which usually tells us what is the degree of freedom there.
Sir, actually, I mean, I don't want to get confused actually. So for the simple mathematic purpose, I mean, in the exam time, I mean, irrespective of sample data, I mean, whether it is below 25 or
Yeah.
25 and more than 25, for the t calculation, I will simply use the
n
n, right?
n yeah,
N.
yeah.
And for the jet, I mean, when for the jet purpose, I will use n minus 1.
Yeah.
Okay, sir. And sir, here you told that the degree of freedom is 23 for that problem.
This problem, yeah, this problem.
Yeah, for this problem. So, sir, how it is? I mean, just the degree of freedom, how 23 has came?
For t-test, it is n minus 1.
And actually, excluding the outlier, the sample was 24.
24
I mean, the
and then n minus 1.
and from that one is minus,
Yeah.
right, sir?
So it will be better, like if you have the thing is it will be better if you can search 2-3 terms in YouTube first. Second thing is, like, one thing is the searching how to determine the degree of freedom. So they will have nice examples, like if you have a table kind of number of rows and number of columns, okay, and number of, like, rows, these are rows, yeah, these are rows and these are columns. So depending on number of rows and number of columns, you can determine what is the degree of freedom. So that will essentially tell what is the thing is. And then if you are interested, you can also learn about this correction factor, why in samples they go for n minus 1 and why for population they go for n.
I will definitely check it. And what you are telling, that in the row and column section, that I already understood. But here actually the confusion arises because the total data set is 25. So when I calculate the degree of freedom, so we I mean, exclude
took
the
24.
outlier or not? That was my question. And I mean in the case of degree of freedom.
Got it.
So you are telling that I mean
We have to
we
exclude the
calculate,
outlier, yeah.
I mean 24 data and minus 1 of it.
Minus 1.
Right, sir? Okay, sir. Thank you.
Thank you, sir.
Yeah, thanks a lot, and
Sir, thank you very much.
yeah,